I've just written out these lines of our 1 plus x expansion again, just because I want to introduce some new notation that will make it easier to work with these things as the numbers start to get larger, and also help us to be able to use our calculators when the time is right. Okay. Now, see these coefficients, right? As you've noticed, they are very predictable. Okay, they come out of here. Not only are they predictable, there's an interesting pattern to them. Okay, such an interesting pattern that I'm going to devote a whole set of new notation to that pattern. Okay, so you can see up here, and I'll add it down for the subsequent lines. I've highlighted the coefficients. Those are the important parts. You can see that regardless of what the other bits inside the binomial expansion are, right? Once you expand them, the coefficients are always going to be these numbers. These numbers are very important, okay? So I'm going to introduce two kind of parallel ways of writing down what these coefficients are with relation to, number one, what's its power, okay? And number two, which coefficient am I interested in? Okay, so another way to say that is, because all of these numbers are the same as these numbers, I'm going to write it in terms of which row I'm in and which number along in the row. Okay, so here's the notation, and this is worth actually making a note of. Note on notation. Okay, this notation, which you'll actually find on your calculator, I'm looking for it, is on mine it's above the multiplication and division signs, is this, nCr. nCr. Another way of writing it, a faster way which I encourage you to do, I think it's better, but you need to be able to recognize both, is the n and the r on top of each other in a set of parentheses, like so. Okay, they mean exactly the same thing. I read them as nCr or nChoose r or n combination r, and the reason for those wordings will become clear later. Okay, what does it mean? In these things here, right, if I were to generalize and to say, what if we raise it to the power of n? Okay, the coefficients will change accordingly, won't they? Okay, they'll give you a new row. It'll be the nth row of Pascal's triangle, right? So, nCr is the coefficient, right? Or actually, it's the particular coefficient, the rth coefficient, in the expansion of whatever to the power of n. Okay, it's the coefficient of 1 plus x to the power of n. There you go. Okay, so if I can give these as some examples, okay, let's go for this one. Let's go for this one in here. If I rewrite this, I'm going to use, I like this, I think it's a bit quicker, and I have to write one less letter. I suppose I have to write percentages, but anyway. What kind of power do I have here? It's a 2, right? So the first thing I'm going to have is 2, C, or choose, or whatever. And the first term is 0, okay? Do you remember before why we said it's a good idea to start with 0 rather than 1? It's because really, there's actually an x to the power of 0 hiding in there. We just don't write it, okay? Because it index level. So there's the first term. The next term will be, I'm still the power of 2, the n hasn't changed, right? But it's the next term along. Okay, now that coefficient attaches to the x, like so. Okay, and of course that means following the pattern, the last term along will be 2 and then a 2. There you go. Okay, I could do the next one as well. What's changed? It's just the power. That's the n, right? So these are all going to be 3 something. 3 1x, 3 2x squared. You can see, sorry, I forgot the x squared there. The power here in this particular expansion always matches this r number, okay? Plus 3 x cubed, okay? So we can use this. It makes it a lot easier to write things, especially when these numbers become very large. We don't really care what they are so long as we know what they signify. Okay.